Now this illustration deals with underground sets of conductors in accordance with 230.2. Now when this was put into the code, it was very helpful to designing engineering firms and electrical contracting firms. Let's just say, for example, that you had one pretty well large service coming in, but you needed to upgrade this service to provide enough power and amps to supply added loads in the facility. Well, if we wanted to have, say, 6 underground runs coming in with 1/0 conductors or larger, then notice at the building we could have 2 or more mains. And these would be classified underground laterals if these laterals and the transformer belong to the utility. And remember, in identifying the service point in earlier chapters, remember we said if the utility hit that transformer with their supply on the primary side and the customer owned that transformer and owned those 6 underground runs to those 6 disconnects you see on the building, then those wiring methods and conductors belong to the owner of the facility. But say, no, that's not the case here. The utility owns the transformer. They own those underground runs to a individual meters or master meter at the transformer, then those are laterals. And utilities usually require them to be at least 2 foot deep when the contractor, if they install them or the utility installs them. However, if that underground runs that you see there, 1/0 or larger, belong to the facility and they use rigid metal conduit, then we know that they could be 6 inches deep is all, if it's rigid metal conduit. If the utility, in conjunction with the electrical ordinance of the state, county, or city, said, no, it doesn't matter who owns those conductors, they would have to be 2 foot. So watch out for that if you're an electrical contractor or an electrician. Know where the service point is. So in this case, if we had a master meter out by the transformer and those runs went in and hit the disconnects and belong to the utility, then most of the time they have to be at least 2 foot deep, or maybe even a little deeper if they're over 1,000 volts, and maybe would have to even be encased with red concrete, or maybe a red ribbon put down to identify them as high voltage. Now, once again, we recommend in the NEC loop for the designing firm, the contractor, and the electrician to review 230.71A, laying the 2 to 6 disconnects you see on the building. 230.72A, well, yes, they have to be grouped. And then 230.80 basically says, if possible, that they should not exceed the ampacity of the conductors without we apply, say, the exception 3 maybe to 230.90A, and if we had loads in that facility that required inrush characteristics to start and run, then those overcurrent devices could be sized larger as identified in table 240.4G that we talked about earlier. So the information above the facility basically says underground services connect together at supply end, but not at service end. So we're looking at the supply end and the service end, and then what's required. Now notice back at the transformer, they're connected together, but they are independently connected to disconnects at the facility. So all this information now is found in this figure 6-7 by reviewing NEC 230.2 to get the permissive rule, and then review the information in the NEC loop.